one of the big problems with closed source is maintenance. VTK basically is stands for Visualization Toolkit. So it's a C++ library that lets you display 3D data in a way that you can analyze it and recover the most salient information. In terms of limitations, there is definitely a limitation in the way ParaView handles temporal data, I would say. FED is basically a fast and minimalist 3D viewer. Basically, it's based on VTK. It's using VTK inside, but as a FED user, you have no idea it's using VTK because it's really its own way of rendering things.
All right, ladies and gentlemen, today we have a very special guest in the podcast, namely Mathieu, who will talk about VTK, ParaView, and what he does on a day-to-day basis. So welcome to the show, Mathieu.
So hey, Joseph, I'm very happy to be here. Should I go ahead and just introduce myself?
Yeah, sure. Go for it.
Okay, so I'm Mathieu Westphal. I'm basically an open source software engineer. I'm working at Kitware. On my day-to-day basis, I basically develop VTK and ParaView. So I hope many of your listeners already know ParaView, I suppose. I also work on other open source projects, which are not as well known, but I will be very happy to present them. To get there, basically, I have just followed software engineer school, and just I've worked for a few years in as a research engineer in France. This is where I started to actually work in open source, because some of the in the French research, there is already some researchers which are actually putting their code as open source. It's basically part of the open science movement, this kind of thing. So this is the first time where I started contributing to open source code on GitHub, this kind of thing. And then after that, I also discovered ParaView used in the French laboratory I was working at. After that, I fell in love with ParaView and VTK and just start using them, working on them at Kitware, and contributing daily to the open source code, and also interacting with the community, which is one of the main, I would say, one of my main motivation for the day-to-day is that the fact that we have a community, and this community in VTK and in ParaView are really engaged with the software and wants to make it better, I would say. That's great.
That's you in a nutshell. Really cool introduction. So maybe you mentioned something in the beginning. Maybe let's dive in there, which is open source. What is your philosophy on open source versus closed source? Like, what is the motivation? Do you have an intrinsic motivation to say, hey, open source is something super cool, I want to work on that? When did you make the decision and why?
This is, well, when you're contributing to open source code, you really feel like you can make an actual impact. The problem with closed source is one of the big problems with closed source is maintenance, because someone developed a software and maybe it's being sold for a few years, and some people are paying for it. There is some money, but then at some point, not that many people are using it. So the vendor of the software just, okay, it's still there, you can download it, but there is no new version, there is no fixes. With open source, of course, it can happen as well. If nobody is using it, using the software, nobody will fix the bugs and everything. But at any point, someone else, which is not at all connected with original developers, then just pick it up, revive it, fix the issues. And so like this, you can see that some project will keep being alive even 20 years after the creation. Sometimes there is a company behind it. Sometimes there is also a consortium behind it. Sometimes it's a community behind it. There is different ways to make an open source project live. But with open source, you have very much the possibility of your software basically outliving you, which is not something that is true for, I would say, small scale closed source software. So yeah, that's one of the main thing. Another thing, which is very important to me as from a very technical point of view, is the fact that when you're writing open source code, you basically commit to write quality code. Of course, you can take a look at any a random GitHub repository, and the code quality will not be good. That can happen, of course. But for truly community open source project, the fact that you have a public review and anybody can look at the code basically forces the developers to say, okay, guys, we need to do something. We need to write something good and something that works correctly, because if we do not, somebody else we come and see, and that's bad code and you need to change that. But with closed source, you basically taking the word of the developer. They say, okay, it's a good software, but you have to trust us. And with open source, that's not the case. And as a developer, even when sometimes I write closed source code, I do not have the same kind of commitment. Maybe I don't have time for tests. Okay, I will not write tests for this closed source code. But with open source, you don't have you must do it. It's part of the way of working with open source code. So in general, the quality of open source code is way higher than quality of closed source code. That's my own. That's a very practical way to define it, I would say.
Yeah, I think that summarizes it well. How would you advise people, let's say they want to contribute to the Kitware solution, so to say, let's say they want to contribute to VTK, ParaView, whatever. How can they contribute? Like, what's the step-by-step instruction?
That's the VTK and ParaView project have made good steps to facilitate this kind of contribution. So basically what you want to start with is go to gitlab.kitware.com and VTK and ParaView project, and then check out the development guide, which will give you instructions on how to build ParaView and VTK, and then how to contribute. That being said, it's a big there is a high barrier of entry, because there is some expectations of the way you're supposed to do things. So I would not say that they are the easiest projects to contribute to if you want to start contributing to open source. As a beginner, I would not suggest you contribute to this project specifically, because they are big project, a bit hard project to contribute to. That being said, if you're used to contribute to open source on GitHub, switching to VTK and ParaView is nothing hard at all. It's just another project.
I see, that makes sense. How does a day of Mathieu look like? Like, I mean, it's an open source project, and I mean, Kitware also has to make money somehow. Yeah. So how does your day-to-day work look like? How do you support companies, for example, in developing their own solutions?
So I'm just giving my own point of view here, not representing Kitware way of saying things, right? So basically, when you create a company around open source, there is different ways to do business. So Kitware is a bit different to other company on that regard, because Kitware is basically selling services. Basically, we are selling engineer time, expertise time, I would say. So there is no web service that you want to pay for. There is a lot of open source companies that do that. They have an open source software that somebody else can just take and put on their own server, like GitLab, for example. GitLab does that. And then they have their own service that they monetize. But at Kitware, we just sell the service around the software, courses, specific development, this kind of thing. But if you're interested, just take a look at Kitware website on that regard.
Mm-hmm. I mean, you talked about the business model of Kitware, right? How does it differ from your competitors? For example, let's say, okay, maybe explicit question is ParaView versus.
Well, TechPlot is not open source, so basically TechPlot selling licenses. So basically the main difference for users that's using TechPlot versus using ParaView is that let's say you found a bug in TechPlot and you want to report it. So there is actually a place you can report bug to TechPlot, but then you have no idea what's happening. Maybe someone will say, okay, thank you for the report, and that's it. And maybe it will be fixed 2 years down the line. Maybe it will not. You just have no control over it. With open source software, for example, with ParaView, if you found a bug and you would like this bug to be fixed, you can actually fix it yourself if you are a developer, or you can contract a company like Kitware to actually fix the bug as an high priority bug if you want to, or you can just wait for the community to fix it at some point if enough people are impacted by this bug, I would say. So that's a really different way to do things. It's much more open. And as a user, you actually have control to the way it's being handled. And if you want to contribute, being time and money, you can do that.
Mm-hmm. When it comes to the engineering services that you mentioned, can you give maybe a a list of services that you offer? Because I think some people listening to this podcast maybe have their own company and they might need your services, Mathieu. So maybe give us a list of things that you actually do for companies.
Basically, support specific development, bug fix. If you have any issues with VTK and ParaView and you want something to change, something to evolve, something to be fixed, you can reach out, definitely.
I see. When it comes to VTK, some people might not know what VTK, the format actually is. Like, what is VTK in the first place and how can an engineer profit from it?
Oh, yeah. So VTK basically is stands for Visualization Toolkit. So it's a C++ library that lets you display 3D data in a way that you can analyze it and recover the most salient information on the data, so you can make decision with your simulation or your in your I would say research process or even engineering process in general. But VTK is a very low-level library, so it can be used directly with Python, for example, with VTK Python, or even there is some high-level libraries that use VTK that you can use directly, and you can just control VTK like that. Or you can take VTK and create your own application based on it. And the range of application you can create with VTK is very large, because you can you can either create a full-blown ParaView with it, because, well, ParaView is a VTK. It's based on VTK, so it's a lot of work, but it can be done. And you can also create your own customer application with some rendering, some buttons and everything. Or you can even create a very minimalist 3D viewer, for example, which is I'm working on an open source 3D viewer which is based on VTK, which basically lets you show any 3D model in a very fast and minimalist way.
Yeah, I think that's very well explained. What would you say are the projects that most fascinated you during your career?
I think
that you can talk about, obviously.
Yeah, definitely. One of the projects I can talk about without any issue is the first time I was working on ParaView. It was before I arrived at Kitware, when I actually discovered ParaView. I was working on this project with sorry, just forgot the name. This was astrophysical project where there was this cometa coming through the solar system, and we actually sent an orbiter and a lander on the cometa. The name of the cometa was Checkmanianov. I don't know if you remember this. It was in 2014. They actually crashed the lander on it, but they did not want to crash, but they crashed it. I don't know if you remember that. Okay, but I actually worked on the software that was supposed to analyze the results of this experiment, and this is the first time I was working on a ParaView plugin, and I understand the level of complexity you can go in your way on customizing ParaView, and that was really insightful and actually make me direct my career into scientific visualization.
You don't only work on scientific visualization, but also you work specifically on ParaView itself and also HPC. So how does that work look like?
So yeah, HPC is its own thing, I would say. It's very different working with HPC than with just desktop application. Thankfully, ParaView is designed to work on HPC. That's really basically that's in the name. Para means that ParaView has been designed at the very beginning to be able to work on HPC and to be able to scale with very big data. But there is some constraints for HPC when you're working with ParaView on HPC, and the problem we have, I would say, is most users just expect ParaView to just work out of the box on HPC, and they just download it from the web and put it on somewhere on the HPC and try to use it. But that's just not how it works. To be able to use ParaView on your HPC, you need an IT services that will actually build it for you and configure it the way it needs to be configured for this specific HPC, so you can actually extract all the performance you want to extract from it. So yeah, there is lots of challenge to be able to use ParaView perfectly on HPC, but it can be done. There is a blog I wrote a few years ago about optimizing your ParaView workflow for HPC that actually tries to give pointers to people so that they can understand why it's not performing as they expect it to perform and find the solutions for that.
That's super interesting. Maybe you can send me the blog and I'll put it down in the description. Definitely. That would be super cool. Some SaaS companies I know, they have used ParaView in the past, but then they switched to solutions like Citron, for example. The question I have is, what are the limitations of ParaView, and when should companies start thinking about using ParaView as a solution? Maybe when do they maybe should use something else?
Well, in terms of limitations, there is definitely a limitation in the way ParaView handles temporal data, I would say. Because if you work with temporal data in ParaView, you will realize that every time you want to move one time step, your whole workflow will re-execute fully. The reader will read the data, and then the filter will execute and everything like that. So we're trying to make improvements in that direction so that we don't need to reprocess everything. But for some specific domains, for example, if you're working with electromagnetism or acoustic data, the fact that the data is temporal and you will want to go from temporal data to frequential data, for example, and ParaView is really not equipped for that because you want to read all the data at the same time, whatever the time step, and time is not handled like that in ParaView. So that's one limitation, I would say, of ParaView. When you want to do something that ParaView is not really well designed for at the really data model level.
I see. Okay, that makes sense. When it comes to 3D renderings, over the years, I think ParaView is one of my favorite software, especially I started it as a student and then still use it to this day. When it comes to renderings, 3D renderings, I think it's incredibly powerful. What is the development there? Like, is there any ongoing development? And also, what does the future hold for ParaView regarding renderings?
So there have been a few developments in the last few years. For example, with ray tracing rendering, which has been present for a few years and improved years after year. Also, the adding of PBR, physically based rendering in ParaView, which was added 3 years ago, and lets you create kind of realistic rendering directly in ParaView without any kind of overhead in terms of rendering time. So this is a recent development for ParaView in terms of rendering. In the future, the big if is the OpenGL situation where we don't know if we'll have OpenGL in the future for macOS or for Windows, if they want to use DirectX, this kind of thing. So we definitely have to offer a solution for that. And we've been working with different technology to improve on that. For example, we've been considering Web GPU as a solution. Of course, we've been considering Vulkan as a solution, but there is lots of constraints if we want to use Vulkan because Apple is not playing ball with Vulkan. They want to create their own solution with Metal, this kind of thing. So I'm going a bit into the technicalities right now, so I'm not sure everyone can follow. But and I also want to mention that we are working on supporting Anari. This is more generic rendering process that also replace OpenGL and will come in the future. So there is different solutions. Nothing is completely fixed right now, but we're working on it.
Yeah, I think also for the listeners, that would be super interesting to do like kind of a step-by-step instruction how to use maybe ray tracing. And I think Kitware has a tutorial on that, how to use a bicar model and then actually use ray tracing on that bicar model. So you can actually, I'm going to put it in the description.
Yeah, definitely,
When we talked about open source, you have your own project working on, F3D, I think it's called.
So we call that FED. The 3 is an E, but we always, nobody say it correctly the first time. That's perfectly fine. So FED is basically a fast and minimalist 3D viewer. Basically, it's based on VTK. It's using VTK inside, but as a FED user, you have no idea it's using VTK because it's really its own way of rendering things. Basically, what you can think about it. Do you know VLC? You know the VLC, right? You can watch any kind of video. You don't need to think about codecs. It works on Linux, Mac OS, Windows. Well, FED is the same idea, but for 3D model. That's basically it. If you have a 3D model, you just double click on it on your desktop, and it just pop open, and you can just look around. You can change a few things. You can change the coloring if you want to change the coloring. You can, and it looks nice because it's using a PBF, physically based rendering, and you can even switch to ray tracing if you want. So in a way, Fed is a more generic tool than ParaView or VTK are, because it's targeted to anyone that's working with 3D data, and not only the scientific community. If you are a game dev, you can definitely use that to visualize your assets or even generate screenshots. If you're doing 3D printing, you can open your models and do anything. You just look at it quickly. You can even integrate it into your desktop, so that you have thumbnails, little images on your files. For any kind of 3D data, it will generate an image, and then your file manager will show the image instead of showing just that's a STL file, and I cannot show you because I don't know how to show it to you. Does that make sense to you?
That definitely makes sense. Also, what about the medical space? I think in the medical space also they use a lot of 3D models.
Yeah, they do. The limitation of medical, I would say, is using a lot with they're working a lot with volumes. So with Fed, you can actually show a volume with the volume rendering and the color map and everything. The thing is, in medical, you usually want to do some kind of crop in the data to see inside the data, or do some kind of contour. And as soon as you do that, you're more in the ParaView space than in the face space, because you want to do some post-processing, right? And Fed doesn't let you place any slices or things like that. So it doesn't fit exactly in that thing. However, if you want with any kind of STL, OBJ, FBX, even a step file from CAD, sorry, you can definitely open step file with Fed.
Yeah, that's super interesting. I'll also put the link down to the GitHub report in the description.
Yeah.
If someone would be interested in following the same path as Mathieu, like working on HPC, ParaView, whatever, what steps would you recommend them to take? What programming language should they take? What kind of resources they should learn from? Maybe add your 2 cents here.
So if you want to work in that space, the space I know best is all the program written in C++. That's the language I know best. But language should not be a limitation, I would say. So what actually matters is not the language, but it's and that's the name of the podcast. It's the engineering mind. This is what matters. I would definitely suggest to study in engineering school. That's the engineering school, of course, focused on IT and on programming and algorithmics and even logic somehow. And then if you want to go to the 3D world, you have to learn about all the 3D space things, transforms, so all the mathematics around 3D. That's really, really important. And once you do that, if you want to go into the open source world, well, there is no school to learn open source right now. You need to go out and just find a project you like, find some issues in the project you like, and then report the issues, and then start picking up the code and start contributing to little things. And little by little, you will find yourself to understand the project, and the maintainer will trust you, and then you will be a contributor, and then you're part of the open source world, and that's it. But you have to go out by yourself.
Definitely. I think it's pretty straightforward, especially for the engineered mind community, who are like a lot of CFD engineers, FEA engineers. Is there any particular development going on for the CFD or FEA space?
I mean, ParaView is definitely a very good solution for CFD. It has a lot of tools that is definitely needed for CFD. It's a basic tool for post-processing in CFD. I would say just keep using ParaView and keep reporting issues. If you find anything that doesn't actually work with your workflow, you want to improve that, just tell us, because we can fix that, we can improve that. This is what matters. Because sometimes we have an issue is that at core, we are developers. We are not actual user of ParaView. Of course, we use it to do some things and test things and all of that, but we do not have the same expertise as a CFD engineer that is using ParaView as a tool. And sometimes we just don't actually understand the problem that users may have, because they are just frustrated and they will try to find a workaround or use another software. But if you report the issue and try to make the developers understand why for your workflow it's not working, then we can fix that and improve that, and not only for you, but for everyone. This is what actually matters.
Mm-hmm. Yeah, that makes sense. Really cool. Mathieu, I think there was the podcast, one of the shortest podcasts. I just asked a question. You literally just answer it short and crisp. So,
sorry, that's really my style.
Yeah, this is your style. I noticed. Maybe is there any closing remarks from you, and especially for the engineering community, or maybe the community working with ParaView? Maybe some last motivating words from Mathieu.
Yeah, sure. So I would say that if you're using ParaView because that's the tool that works for you, it's great. But it's also keep in mind that's an open source tool, and I'm very happy about the fact that ParaView as an open source tool is now the de facto reference for post processing for in many domains. But as a user, keep in mind that you want to contribute back, and to contribute back, there is different ways to do that. But the very simplest way is to just, if you find a problem, just tell us. If you have time to contribute or even money to contribute, it's something to consider. And you can also come and say thanks to the developers that go a very long way and keep us motivated and all that.
Amazing. So first of all, thank you, Mathieu, for participating in this podcast.
That was great.
It was a quite short podcast, but I think people will definitely enjoy it. Maybe we have a second session in the future talking about a different topic if you want to.
Yeah, sure, definitely. I'm open.
Amazing, Mathieu. Have a nice day and talk to you soon.
All right, thanks.